What if the everyday objects all around us, like our coffee makers or fitness trackers, could do more than just be smart? What if they could actually learn and adapt all on their own without needing to phone home to the cloud or a powerful computer? Well, let's dive in and take a look at the groundbreaking tech that's making this a reality right now.
Okay, take a look at this. At first glance, it seems simple, right? Someone writes a number on a touchpad and the number pops up. But here's the real magic. All of the artificial intelligence, the complex feature extraction, the actual recognition of what you wrote, it's all happening inside that tiny little touchpad. There's no PC, no server, no hidden computer helping out.
So, yeah, that brings us to the million-dollar question. How in the world do you cram an entire AI system, one that's fast and accurate, onto a cheap, simple little microcontroller like the one inside that pad? Well, the answer lies in a completely different way of thinking about AI. Instead of relying on these massive, power-hungry cloud servers for brain power, this approach puts the brain directly onto the chip itself. And this is it. It's called AIfES, which stands for Artificial Intelligence for Embedded Systems. It was developed by the Fraunhofer Institute over in Germany, and here's the key. It's not just another big server AI that's been shrunk down. It's a whole new framework built from the ground up in the C programming language, specifically to be incredibly lightweight and efficient for the smallest of devices. Now, you've got to focus on one word here because it changes everything. Train. See, most small AI can only do what's called inference, which basically means using a model that's already been trained. But AIfES lets the device itself actually learn directly from its sensors. We're talking about training an AI on an 8-bit arduino Uno. That's hardware that makers and hobbyists have been using for years. It's the difference between a device that's just smart and one that can actually get smarter over time. And that's really the fundamental difference. A lot of the popular AI frameworks out there for the edge are just slimmed-down versions of these giant server frameworks. They're still often way too big and clunky for the really tiny, low-power chips that are in everything. AIfES, on the other hand, was born for these environments. And here's the number to prove it: 54%. In their tests, the Fraunhofer team found that AIfES can slash memory usage by up to 54% compared to TensorFlow Lite for microcontrollers. That's not just a small tweak, it's a massive saving that kicks the door wide open for so many more devices to become truly intelligent. This incredible efficiency is why AIfES is part of a much bigger and, honestly, super exciting field called Tiny ML, or Tiny Machine Learning. And the implications of this stuff are absolutely huge. So think about it. When a device can handle all of its own data locally, you get these amazing advantages. First, privacy. Your personal, sensitive data never has to be sent to some random server in the cloud. Second, you get zero latency. It's instant, because there's no round trip for the data. And finally, it's just plain more reliable. The device keeps on working even if your Wi-Fi goes down. And this is the perfect way to picture it. We're basically decentralizing intelligence, giving every tiny little embedded system its very own brain to process information right where it's collected. And get this, there's a massive environmental benefit here too. Instead of relying on these gigantic, power-hungry data centers, TinyML runs on devices that often sip just milliwatts of power. By cutting down on data transmission and all that server processing, this approach to AI is a huge win for energy conservation and actually helps support climate action. Okay, so with all that in mind, what can we actually do with this tech? Well, this is where it gets really fun. The applications are practically limitless. Think about gesture recognition. Instead of you having to learn some weird pre-programmed gesture, the device can learn your unique movements. You could teach your smartwatch to recognize a specific flick of your wrist to silence a call, all without ever plugging it into a computer. Or, in a factory, you could have a tiny sensor that just listens to the hum of a machine or monitors its electrical current. By learning the normal patterns, it can actually predict a failure before it happens, which can save a ton of time and money. Now, this is where it could literally be a lifesaver. Imagine a small, battery-powered wearable that learns your personal ECG patterns to spot something like atrial fibrillation, or uses its motion sensor to know if you've fallen and sends an alert. And since all the processing happens on the device, your sensitive medical data stays completely private. And a list just keeps going on and going. We're talking tiny sensors that can detect specific gases or even smells. Smart cameras that can recognize a person is nearby without needing facial recognition in the cloud. Smart home devices that learn your habits. You can even run simple, fun, interactive games on the most basic hardware you can imagine. Now, here's the really exciting part. This isn't some far-off, futuristic technology that's locked away in a lab. It is accessible to developers and makers and hobbyists right now.
AIfES is open source for personal and open source projects. And get this, you can find it directly in the Arduino Library Manager, which, if you're a maker, you know is a huge deal. Plus, it's designed to work with the tools you're probably already using, like Keras and PyTorch, so you can easily convert your existing models. So if you're a developer and you're thinking, I want to try this, the path to getting started is incredibly straightforward. You just install the library in the Arduino IDE, use their converter tool for your AI model, and start tinkering with the examples they provide, like one that trains a device to recognize the color of different fruits. It's that easy to start. And that really brings us to the final thought here. We're moving from a world of just smart devices to a world of truly learning devices. The tools to build this future are becoming more accessible every single day. So the real question is, when you can give a brain to almost any object, what will you build?